Okay, so I'm really going to be talking about multiple statements, multiple attitudinal statements, and modern ways now in which these can be looked at using modern statistical techniques. So it's commonplace in social science. We've all seen surveys with long lists of attitudinal statements, but there's very little guidance, I suppose. Guidance tends to be stuck a bit in the 1960s, 1970s about how to model such data. So I'm suggesting that this talk is a kind of statistical overview of what can be done to attitudinal data. And there are various methodologies, and the one you choose may well depend upon your philosophy and the purpose of the analysis. So you might be interested in score building, in building some measure of the underlying construct, which a set of attitudinal items are trying to measure. Or you might be more interested in how covariates, how explanatory variables are affecting that attitude. So we'll see, and philosophy really addresses how you view the measurement of attitudes. So, well, obviously we can't cover the whole detail in 25 minutes. So it's a quick summary. Well, we've already heard about Likert items. There's a standard 5-point Likert item. We've all seen no, strongly disagree, neither agree nor disagree. But the scale is bipolar. So you have disagree on one end and agree on the other, balancing two contrasting attributes. And you can have 7 points or 9 points, and it's also possible to remove the neutral point. Those are called false choice items, where people are forced to choose between agree or disagree. There's no central point to allow people to cop out of making a choice. Right, an alternative form of item is a unipolar item. And some people refer to this as a Likert item. Some purists say that this is not a Likert item, and reserve the term Likert for bipolar items. But this really is measuring the strength or the degree of agreement. There are no there aren't two contrasting attributes, just a single measure of strength. And as Georgia says, there's a literature out there on how respondents deal with such items, and wording effects, whether you put numbers against the item. So if you have very important equals 6, important equals 3, and so on, people the way that people fill in these questionnaires will vary according to how these items are presented in surveys. There is a whole literature which you need to be aware of, really, to understand wording effects and the effect that they have. And that really impinges on whether you believe that the fourth item is actually measuring in a kind of absolute sense the strength of agreement, or your balance between agree and disagree, or whether it would vary from person to person. Just as an aside, I'm saying Likert. I was amused to come across this on the web. If you're in the US, you'll find that people will say Likert. Well, we say Likert, they say Likert. I think there's some evidence that Likert is the right way of pronouncing the word from the family. So, but those Americans here, I'm saying Likert. Okay. Yes, there are other forms of measurement which I'm not really going to focus on. You can have continuous rating scales. You have a line and you're asked to put a cross on the line with some form of anchor points either end. So you can have an anchor point there measuring strongly agree, an anchor point there measuring strongly disagree, and then you put a cross somewhere on those lines, and you measure the distance. That will convert a kind of ordered scale into a continuous scale. Ranking methods are used occasionally, but are not analysed correctly, where participants are asked to rank a set of items into order. Or partial ranks, they're asked to choose the top and then the next top, or the best and the worst. Numerous ways of doing this, partial rank data. Of course, survey respondents don't like to be shoehorned into such measures, and so they will often try to subvert the intention of the researcher by doing strange things, ranking, giving the same item to be preferred for the most preferred and then next most preferred. That will mean something to the person filling in the questionnaire, but it's hard to gauge what that person meant when you come to analyse it. The third way, which I'm going to talk about briefly, is pair comparison methods, where you have a set of objects and people and you form sets of pairs of those objects and say which of these do you prefer, which of these attitude is stronger, which is that can be an alternative way of measuring attitudes, but it's a relative attitude. You're asked to choose which is the strongest, or which is the one you most agree with. There's no absolute measure of the attitude. It simply ranks the questionnaire items. So I'm going to take a question. First of all, from the ISSP 2000. This is a data set which is on ESDS, but unfortunately it's not available online. You need to download it from CD. So it's to do with the dangerousness of different types of pollution. Here's a question about cars. Is the atmospheric pollution caused by cars extremely dangerous and not dangerous at all? So it's a unipolar scale. I've called it a Likert item. I'm not a purist. But there are a set of explanatory variables as well, which may well affect your views on that. So I've extracted two countries, simply to keep the analysis in the complexity of the analysis down. So I'm looking at Great Britain and Austria. There's an urban variable, which is urban, suburbs, and rural, sex, age in three categories, and educational level. Educational level is difficult to reconcile across countries, but we've had a go at that. Well, Likert proposed giving a numerical score to each category, typically -2, -1, 0, 1, and 2. But there's a lot of empirical evidence that people don't view the Likert scale in that way, and that the endpoints are further away than the three midpoints. Well, Tony Fielding has written a paper on this in Series A, 1999, and has described a kind of wide variety of ways in which a Likert scale might be scored, and he looks at two methods, Reddit scores and CMS, conditional mean scoring, before rejecting them and really suggesting that using ordinal regression is a better way to go rather than trying to adjust the score. So with a single item, I'm going to run through this quickly. Numerous methods have been used, linear regression, but where we're just taking the scores, -2, -1, 1, 0, 1, 2. It assumes that that's an equally spaced scale, but of course it may not be. It also assumes that the underlying distribution is normal. Once you've accounted for the explanatory variables, what's left over comes from a normal distribution. And that may also not be true. Doesn't stop people doing it. Non-parametric methods is often done by psychologists and others to try and get around the normality problem and also the equally spaced problem. But they can only account for a limited number of explanatory variables, one and at the most two. So that really doesn't take you very far. So we're really looking at ordinal regression as a suitable way forward for a single item. And so we have a model whereby we're looking at the probability of being in a particular category or a category lower in score than that category. So you could be in category 3, 2 or 1, or category 2 or 1, or category 1. J goes, in this model, goes 1, 2, 3 and 4. For a 5-point scale, probability of less than or equal to 5 will always be 1 because you're taking the whole set of responses. So we're modeling that as a logit. So this is similar in a way to a logistic model, apart from the fact we're looking at cumulative probabilities. And then for each J, we have what are called cut point parameters. And then we have a set of covariates. And this minus sign comes in so that the beta is easily interpretable. If the beta is negative, then it's a pull more towards the low end of the scale. If the beta is positive, it's a pull more to the high end of the scale. So the concept really is that we have something like this. There's an underlying continuous distribution, which is your internal way of viewing that particular concept about atmospheric pollution of cars. The effect of the covariates is really to pull that distribution one way or another. So if it moves to the left, if the effect of female is to move that distribution to the left, the cut points stay fixed, and we'll end up with more people in group A and fewer people in group C. So if group A is response 1, group B is response 2, and group C is response 3, we'll have more females saying that cars are very dangerous, and fewer females saying cars are not dangerous at all in terms of pollution. So that's the underlying construct and the underlying philosophy. The cut points stay fixed, and you kind of shift the distribution up and down according to your explanatory variables. So having said that, you can fit this model in virtually any statistical package you care to name now. In particular, SPSS, R, using function CLMM in package ordinal, Stata, and I'm sure you can do it in SAS as well, but I haven't looked at. So if we do that, then we can see, for example, that this is a kind of halfway house in terms of analysis. I've taken out the urban factor and age as not being important. We can also see that sex is not important there because the p-value is above 0.05. But we can see that education and country are both important. Country has a negative view, and that's assessing the effect of Austria. The second educational level is those with A level or above. So those with greater education are more likely to respond with low values, and low values are the extreme dangerousness. So that's, if you have more education, you're more likely to be at the low end of the scale, which is the dangerous end. And the same with UK. UK more likely to respond with dangerous. But this is working on the absolute value of the response. It's taking that numerical scale and saying, how does that vary? Now, it might be that people in Austria have a different way of interpreting what that scale means to people in the UK because of cultural reasons. So there is an issue about whether we should be using an absolute measure. So the idea of threshold, this slide is probably in the wrong order. The idea is you have an underlying view, and you're trying to position yourself in one of these categories. So what's your day like today? Well, is it great day is one. What's a day like any other? Well, it's a really awful day. But you may be somewhere in between, and therefore you're making a judgment about which category you should go into. So you're being shoehorned into categories, but your view of that scale may be continuous. So that's a single item, but most people want to look at multiple items, and in fact in the ISSP 2000 there were 6 items, including a statement on genetic modification, fits in well with the first talk. These are all measured on the same scale. And what can we do? Well, there are a number of traditional methods, first of all. So going back to Likert said, well, we give scores to these categories, and then we can just sum the scores, or find the mean of the scores, and then we can analyse that as being a Likert scale. So, and the advantage for that is you get a score for each respondent. It's a straightforward method, and you can model that score. But the modelling and the estimation of the score are separate, first of all. It assumes that the categories are equally spaced, although you can give your own scoring to those. You're not trying to estimate the scoring. And really, moving on 80 years, we can do a lot better now. The other thing that's often done is principal component analysis or factor analysis on these sets of items. Just by plugging the variables into a standard PCA or factor analysis program. And many statistical and psychological texts warn against doing this, but it's still done quite regularly. Well, maybe there's some validity if you're using 7 or 9-point scales, but it's a typical thing you can do. Well, the advantages are pretty much the same. You can end up with a factor score, which gives you a score for each individual, which can then be modelled, but again assumes that the categories are equally spaced, and the assumption of underlying normality is also a difficult one. So those are really traditional methods, which are still around, but really are not now with modern techniques, are really starting to be replaced. Euroscope, who was the person behind Lisrael, one of the structural equation modelling packages, makes a statement: ordinal variables are not continuous variables and should not be treated as if they are. It's common practice to treat scores 1, 2, 3 assigned to categories as if they have metric properties. So Euroscore is just one of the people warning against using techniques designed for continuous data on sets of ordinal data, on sets of ordinal items. Well, there are numerous ways now which have been proposed, and in modern structural equation modelling packages like M+, but also AMOS and so on, EQS, Lisrael. The one way of doing it is to use factor analysis ideas, but to replace the correlation. To replace the correlation from the standard Pearson correlation for continuous data to something called polychoric correlation, whereby if you have 2 variables with a single cut point in each, so we're looking at 2-point scales rather than 5-point scales, it's easy to draw. We'd have data that would look like A, B, C, and D if we started to look at correlation. But then we assume that there's an underlying normal distribution, like the cut points I showed you on that distribution, and would estimate the correlation from that underlying normal distribution. So that's really one way for which these more modern packages could deal with data. An alternative view, which is really more related to explanatory variables, is to deal with item response models. And item response models attempt to estimate both item scores and scores for the individual questions, and also scores for the individuals who are taking those sets of items. And normally we estimate one of those, so we may be interested in the individuals, but not in scores for the questions, or we may be interested in ranking the questions and not really so much about the individuals. For ordinal data, these are called graded response models. But it turns out that graded response models are really just another form of multi-level model. Multi-level models have been big in social statistics for the past 30 years, and they can now be fitted to ordinal data. I've used R to do that, using function CLMM in the package ordinal. But basically we would have individual would then be a random effect, and we have question response within each person. We have six responses for each person. Or possibly five for some and 4 for some. It doesn't matter. The missing data would sort itself out because we can use full information in carrying out that analysis. So that's the good news. And the model now becomes rather more complicated. We have a set of cut points. We have a random effect for the individual. We have an effect of covariates, and we have an effect for each question. So we can measure the strength of dangerousness for each question. And what we end up with, first of all, the first 6 lines will be the strength of dangerousness. And if you remember, a negative sign means more danger. So we can see that industry, I, in there, is the most dangerous. It has the most negative score. T, temperature, global warming, is the next. Right at the bottom, cars and genetic modification is thought of as the least dangerous. And then we can now see that once we've moved away from the single item, we have Austria now as being, over all the items, would rate environmental dangerousness, would be more concerned about environmental dangerousness than the UK. Females are also more concerned. So that does both bits. We can look at the questions, we can rank the questions, and we can assess the effect of explanatory variables. So I think multi-level models have a lot to offer in the analysis of multiple attitudinal scales. I just really wanted to briefly talk about paired comparisons. Well, here's a set of responses. We have car, ind, farm. Low value is more dangerous, so we can see that industry is considered to be dangerous, cars considered not to be so dangerous, and we can make paired comparisons in terms of the level of dangerousness. So if we look at industry and car, we can see that industry is considered more dangerous than car pollution. We have equality if we confirm farm pollution, if we compare farm pollution to water pollution. I won't go through the details, but this is now relative. We're getting rid of the absolute value. All we're doing is comparing these items in a relative way. So we've taken out the absolute value, and we can simply compare the relative ordering of these. And there's a paper in statistical modelling that does this. I won't go into the details. What's the advantage? Well, relative is... many authors have criticised the use of absolute values because there are cultural differences between countries, maybe differences between genders or age groups, in interpreting these levels of Likert scales in different ways. So some cultures may be very reluctant to go to the endpoints. Well, pair comparison models can be fitted in R using the package prefmod. This is the type of thing that you get out. So for Great Britain, we can see that genetic modification is right at the bottom. That's least environmentally dangerous. Water pollution and industrial pollution is considered to be at the highest. Global warming, temperature, which is the T on that diagram, is a concern for young males, but not a concern for older groups and so on. If you compare that to Austria, we can see global warming is right at the top in that list, and water is way down. Austria's water purity is very good. Comes from mountain ranges, so on the whole, people are not so concerned, maybe, about water pollution. This is nearly the last slide, but it's good I put this in because George was talking about latent class analysis. You can also do a latent class analysis of attitudes. Completely different approach. What we're looking for is segmentation or clustering of people. Say, how many clusters? Well, I did this very quickly. I don't know whether there are 3 classes or 4 classes or 5 classes in this. If we fit a 3-class model, we have a group comes out that those tending to rate every item as very dangerous. Really, environmental. And the end of the world is now, thinking that everything is going to cause problem in the environment. The other group are those who are not concerned at all. Well, concerned a little bit. They're somewhat dangerous, but are 24% of the sample, and then a big group in the middle, 54%, giving more variable answers. If we fitted more latent classes, that 54% would be split up into further groups. But I just wanted to illustrate it very quickly. And there's a great package called Latent Gold that can fit latent class models very easily. So I think my conclusions are, depending on the purpose of the analysis, if you're into score building, you could use structural equation modeling approaches using polycorrelations. But ordinal mixed effects regression was what I showed you, the idea of a multi-level model with an ordinal dependent variable shows promise, should say. Shows promise rather than shows, well, how promise. Pair comparison approach is if you don't believe in an absolute measure, but simply want to look at relative differences. How does the rank ordering of items differ from males to females, differ from country to country? So that's very useful for getting rid of that absolute value. The latent class offers a completely different viewpoint in terms of segmentation. It's not assuming an underlying construct at all, but looking to see how different groups of people answer these 6 items differently.